Vanakkam, Namaste, Namaskar. Welcome back to Jalprayag. I'm going to take in a question on again on SFBM, and the reason for that was I want to continue on the same principles which I had given to you in the last two modules. I had done the concept second time, and I had solved one cantilever beam on the last video. I want to solve this question which was earlier attempted, and a few of the videos in YouTube have this solution. There is some discrepancy in the way people are solving. Uh, there is something which was missing in the calculation. So I've tried to correct it and present it. Basically, I'm presenting it again. And let us see what is the change, what is expected, and what was missing before. And I'll try to maintain exactly one single method in this particular question, which I have been always telling again and again that let me take only one side. And I told you before also that people in other videos are taking from one side, let us say left side, and suddenly they change over to the right side. It looks simpler, but for a lot of people, if you don't know the concept of these equilibriums, it will be difficult for you to try whenever a new question comes. So with this solution, I I can tell you that at least you can solve any type of question if you follow this one concept and one procedure which I have been following in this particular video. So I suggest please have a look, try it. You're free still to comment on this, and you can give me any other question which I'll try to solve also, but I'll try to stick on to exactly the same principles. I will not change anywhere. So as usual, I will always try to take left hand calculations as my reference. So I'm going to stick on to every calculation based on left hand. That means I stand on a frame and then I go only on the left side. So that is what I'm going to stick on. My strong suggestions for those people who had doubts earlier and the people who have joined in, maybe you are joining in right now. Please watch these videos if possible before, particularly 95 and 96. Your 80 series will talk about all small basic questions where you don't have doubt because most of the questions were with the twin supports. So usually wherever you have twin supports in any beam, the calculations are very easy and you can just play with the method. But the moment the question comes with a single support, that doesn't matter it's a single supported overhanging structure or single support cantilever structure. The way the calculation is to be done because of equilibriums is different. So once you see this video, which is right now 97, you can apply this concept to any kind of question and you will never go wrong. Uh, Please try it and you can always see that you will get it. And as I said, that I can always solve more questions based on the single concept which I'm going to use in this video. So I suggest please look at the concepts. I'm going to repeat the concepts a little bit, whatever is needed for this question, not everything, but we'll see. It is the same question, November 2023. There's a uniform log AB, 15-meter long. It weighs 150 kilonewtons, supported at midpoint. It is not a point support, please remember, it's a flat support. So it also carries a point load of 45 kilonewton at extreme end called Bravo. They want SFBM diagram with 3-meter intervals. So let us do the beam diagram first based on the question. Nothing different, whatever is given to the question. It's a UDL, so uniform body distribution is there. Total weight is 150 kilonewton. So I'm going to show you at COG. Why? Because before I start any question, I need to do the reactions. So for reactions, please always try to give the total body weight at the center of gravity. That is how you do it. When we go to individual SFBM, we will break into frames. So right now I'm not breaking them. Frames are 3 meters apart and A and B being the ends. So one suggestion, people ask, why can't I do A, B, C, D? Now you could have done if this question did not name it as AB. So that means please stick on to this. Let us not have any doubt. So since the question says AB are the two ends, so I'll stick on to AB as two ends. Each frame is 3 meters. So this is what I will mark it. This is a concentrated load, 45 kilonewtons. Here I marked it. It rests on a 3 meter platform. Please remember, it is not a point support, it is a flat support. So things will change a little bit. And this was the whole problem because it was not a point load and it was a flat support. And whenever you do the calculations, there is a possibility of discrepancy, which I'll point it out a little bit later. The shear force will not change much, so it'll be still the same. So I'm going to show you the equilibriums, which I'm supposed to use in every question. There are three equilibriums in your beam. The first one is vertical equilibrium. That means all vertical action alone. That means only the forces should be equal to the reactions. The second ones are turning moments. Turning moments, please remember, have to balance each other. That means any clockwise turning moment should balance each to the anti-clockwise. Now, what is a moment? Moment is nothing but a rotational moment. And why is it generated? It is generated because of the vertical forces which are there in point number one, the vertical forces. Then you'll have a perpendicular distance called lever. So this is the reason for the moments. You need to do that also. Then there's a last one called horizontal forces also. But I'm going to discard this because this particular beam does not generate any horizontal forces. So we will discard this. We're going to look only at 1 and 2. That is what is needed for SF and PM. Okay, let us look at action reaction calculations. First one is for the shear force. Shear force is purely vertical forces. So vertical forces actions should be equal and opposite to your vertical reactions, which means they should sum to zero, the sum of all forces to zero. Now please see here. This is what I told you that I'm going to stick on from now onwards. Any question I start, I'm going to take forces only on the left side. So that means if you want to take a total equilibrium on left side, I should be at Bravo. Then only I can do this. So I'm sticking on to this. I'm standing at Bravo and I'm going to use only the left side forces. For that, I need a sign convention. Please see here, I'm highlighting a sign convention. If I am standing at Bravo, all forces going upwards will be called positive. All forces going downwards will be called negative. So based on that, please see the vertical reaction calculation. It is simple. For me, all the action forces here in this question, which is your body weight as well as your point load, they are all acting downwards. They are negative forces. And very evident that I have only one support. And this all this body weight which is going down has to be resisted. So that means I should have a reaction in the opposite direction. That is why vertical reaction I've put it as plus. We will see that your answer also will come as plus. I've clearly marked full body weight as minus 150 and minus 45 is the point load. When you equate it, when you push these values to the other side of the zero or equal to, you will get vertical reaction as plus 195. So this is what I'm showing you as plus 195. So right now, actually, I'm ready for my SF calculation, provided I break this 150 kilonewtons, which is the body UDL, into individual forces between the frames. Okay, let us divide them and then I will be starting off. SF, please remember I will always use left side of any frame. So if I start from A, C, D, E, I will use only left side forces. And left side forces, the direction is still the same as the previous picture I showed you. Any force going up is positive, any force going down is negative. Now I need to distribute this uniformly. So I'm going to show you how I'm going to distribute. This is going to be 30 kilonewton. Please remember, the moment I distribute 30 kilonewton into this 5 frames or 5 spacings, I should discard the total 150. This is a common mistake which a lot of students do. What they do is they divide them into 30 also, and they forget to remove that 150. Please remember this 30 into 5 times came because of that 150. So when I start doing SF calculation BM, I should remove that 150. So please look at this diagram. I have removed that 150 completely, and I've distributed all of them with 30 kilonewtons facing downwards. Now there's a small catch. If you can see on the top, I have given you a note. No need to modify the reaction, which is 195 between D and E right now. But after some time, I might have to do it if I need to. Let us see if I need or not. I'm starting from A. I'll be taking this symbols. On the left side, all forces upwards is positive and all forces downwards is negative. I'm going to stick to this. Let me start with A. No forces on A and left of A, so that means it's 0. Let me come to Charlie. When I come to Charlie, you will see there is one force which is acting downwards at 30 kilonewtons, so minus 30. So please remember, this is basically matching with exactly the sign convention I've shown you here. Let me go to delta. I have minus 32 times, so it is minus 60. Okay. Now, you can actually in the question directly jump to echo because that is the next frame. Normally, we always draw SF and BM only on the frames, but I would like to calculate one which is exactly at the center also because that will help me to give me a better diagram of SF and BM. Otherwise, you don't have any ordinates between D and E, and that is already it is 3 meters long. So it is quite long. So what I'm going to do is I'm going to create an artificial point, a midpoint called X. This is what I've written on the top note. Can you see? If I want the forces at X, then I need to split. I need to split. I need to split them. Why? Because at X, you should remember the reaction also is not a point load, it is a distributed load. The purple color or the violet color, uh, the frame what I've given you on the bottom is a support. It is a uniformly distributed support. So if I call this midpoint as X, actually there is no need for me to calculate, but I'm going to do it to get a better picture of my SF and BM diagrams. I'm going to do it. So in real life, there's no need for you to do it, but I will do it. Let us see what it comes. This intermediate point X, please remember left of it and right of it doesn't matter. Left of it, it is a uniform reaction and uniform action. Please remember for this between D and X, I need to show at the center of gravity. So see, I'm going to show you center of gravity. I've divided that 195 into 2. So this is how it will be. And there was a 30 kilonewton below exactly at X. That also I have to divide at the center of gravity. Now, this is the right picture for me to calculate your SF and SF forces, resultant forces at your X. So when I do it, you please see what I get. I'm standing at X. What do you have on the left side? I already have minus 60, the big ones. Then I have this minus 15 also. Then what is positive on my left side? I have only 197.5. You will see the summation gives me 22.5 plus. So this is a good value for me to do a better graph. So that is why I'm sticking. My next aim is to go to echo. If I go to echo, I can discard this individual distributed load, which I just showed you on the previous page. There's no need. Why? Because it is totally there and I can use the total 3 meters between D and E's reaction and action together as one force. So in that case, I'm going to get this. Totally 195 plus, and I have minus 90 on the bottom side. When I go to F, again, I don't need any distribution. I just can take the total. And when I go to B, please remember B is a point load. Remember X was not a point load. That is why I did not have two values, but B is a point load. Whenever you have point load, I will have two values. First, let me see what is exactly left of B. Left of B is plus 45. But exactly at 45, I have a minus 45, which means when I finish the total calculation, I will have two values. The left side was 45, and the right side is a summation of that plus 45 and minus 45, which will give me 0. So at Bravo, I will have two vertical forces, 45 to 0. This is how you should write. Till now, there is no difference from what we did earlier also. As I said, I had attempted this question before, but there was no difference. So for me, nothing is changed except that I have broken an extra value at X-ray, and remaining values are exactly the same. I will draw the SF diagram later on a single ordinate after find BM. So till SF, you should not have any confusion. Let us go to BM. And this is where a kind of discrepancy starts between various people solving these questions. And let me sort that out. I have taken off that discrepancy and I'll show you the complete calculation. BM, as usual, I'm going to take left side. I'm going to stick to one concept, but there is something else you need to understand here. If you look at this right side page, uh, the bottom part of it looks very similar. Before I calculate, I'm going to give you some logical conclusions. So that means I should know what I should expect. So I'm going to show you what I'm going to expect from the calculations. Please see this. This is how this whole beam is going to behave. This has got a point load on the starboard side or the right side. And this is A and B. By looking at this diagram, I can tell that the body weight on the left and the body weight on the right plus your point load is going to make this beam at the ends go down. And if you can see these two motions, rotational motions, it will look very similar to this negative bending moment. So I'm going to give you a conclusion right now. This is what I'm going to expect when I start the question. This is what I should expect. The beam is going to hog. Okay. Let us assume for just a minute, assume that X was not a flat support, it was a pin support. So pin support will look like this, single point support. Okay. If you had a pin support, please remember there's possibility this beam can rotate. Whenever you are allowing a beam to do something free motion because of an action, then that means there will be no reaction. But the problem is this is not a pin support. So that means I'm going to cancel these two. This is not a pin support, it's a flat support. And when you have flat support, it is going to resist the rotation. So that means whenever something is resisting a motion, you will have a reaction. So that means I will have a BM reaction here and I need to calculate. That is the whole concept, which sometimes is missing in some of the calculations. So I'm supposed to calculate BM reaction. So let us see how to go about it. My conclusion, at left hand A, BM will be 0, right hand B, BM will be 0, and midpoint X, BM will be maximum. This is what I'm expecting out of this question, and let us see if we can get that. Please look at this. Again, I'm doing some hypothetical free body diagram. This is called free body diagram. I'm splitting this into two pieces. See here, left side also 7.5 meters, right side. But you will see some small thing differently here. On the left side, I have total body weight 75. But on the right side, I have this 75 plus 45. This itself tells you the left side BM diagram and the right side BM diagram from X will not be symmetrical. They will not be symmetrical. You will have more stresses on the right side because of this extra weight called 45. Okay. So what does it mean as a free body diagram? When two forces at the ends are trying to push you down, you will feel as if the beam at X will tend to lift here, and the right side beam at X again will tend to lift here. This is what will happen. These are both of them in the middle. What I've shown you are called actions. Please remember, actions. These actions should be resisted and they should be kept at the flat piece without being lifted. So that means I will have a reaction. So anything which is the flat support is resisting your lifting up, so you'll have a reaction. So this is what I've shown you as an action. Please remember what is happening. These are two actions. Now, as and when I have resistance, that means the flat support is not allowing this beam to be lifted up. It is because of some reactions. So the reaction has to be exactly opposite in these two directions. These two are not separate reactions. They are a combined reactions. I'm going to show you what is a combined picture of this. And this combined reaction I'm supposed to find. This is what I'm supposed to find before I start the problem. Again, can you see both these blue color reactions are also trying to give me a hogging moment. So that means for me it's confirmed that this beam is going to hog. Now, hypothetically, again, I've shown you the two different pieces as two different cantilevers. And by looking at this cantilever, you should immediately realize the bending moment at X will be maximum. And you can see I've shown you two separate approximate bending moments, which I'm going to get or I'm going to anticipate. Both these curves, they have the different maximums, but they will merge together. So when I merge them together, this is how I'm expecting my final bending moment curve to be looking like. This is what I will get. They are not symmetrical. The forces on the right side are a little bit more. So this is all a diagram to show you that what I should expect before I start a question. Now let me start the question. What I am supposed to do is I am supposed to find this combined reaction which is being generated because of the actions. So these are two combined reactions. So I'm going to again, please use, remember I'm going to use the bending moment equilibrium, your formula. Your X at X, I have a reaction. So that is due to the weight and the load acting at the free ends. So my job is to calculate the moment reactions. Let us calculate it. Okay. I'm going to take this again diagram for rotational forces and the vertical forces. I'm going to use left hand side. I'm going to use left hand side. So if I want a combined single equilibrium equation, and if I want only the left side to be taken, I will have to stand at Bravo. So for me, this is the direction I'm going to look. I will stand at Bravo. This is what I did for the vertical reactions also, and I'm going to do for moment reactions also. Please see this sign convention. The moments are caused by force and perpendicular distance. So I'm going to use this force signs, and the moment also what I generate also I'm going to use these signs. These are the signs I'm going to use. Let us see. Sum of all BM actions and reactions should be 0. So I'm forming an equation. If you had seen the direction of the reaction which I showed you, they were uh, trying to tend to give me a hog. They were trying to tend to give me a hog. Okay. So let me start off from right end. From right end, I have formed an equation. I want to find moment reaction. So I have given that as MR. What is the total body weight doing? The total body weight is acting downwards. So that means it is a minus 150. Equilibrium is at center of gravity. So I'm going to take it 7.5. Please remember 7.5, not the whole length. It is 7.5. That is where the whole 150 is acting. Where is the 195 acting? Again, it is acting at 7.5 from Bravo. So you can see the downward forces and center of gravity is 7.5. Upward force, which I calculate as a reaction, vertical forces is also, which is positive as per the sign convention. And this point load at Bravo, please remember it is acting downwards. So it has to be taken negative, but there is no lever. So it is 0. So when I solve this equation, you will see I'll get these values, and the final value comes to me as minus 337.5. The word minus clearly tells you that the reaction is going downwards, which is going to create a hog effect. Okay, it is going to create a hog effect, and let us see with this value how to start my calculation. I have found out, at last I have found out what is the moment reaction. Let me point this out. A lot of calculations in the videos are not showing this one moment reaction. That is the reason some pictures are not correct as per the equilibrium. So I'm going to use this minus 337.5, which is actually acting exactly here in this direction. I have already shown you what is minus 337, so it has to create a hog effect. So this is what uh, is the direction of the reaction, moment reaction. So I'm going to take as minus 337. Now let us look at the forces. If you uh, don't want any values at x, then I can do the total forces up and down, which is your 195. Remember, it is 195, which is going up. And between D and E, there is a minus 30, which is going down. I could have done that. But I'm going to use the X value also to get a better picture. So let us see what is the X value. Otherwise, I will not get a maximum value. I don't know where to go and turn. So I need that X value. The vertical action reaction on the flat platform, please remember, is uniformly distributed. It is not a point force. So that is why I'm going to split them again. Similarly, what I did in your SF calculation. And this will help me for calculation of X. If I don't need this, I could have directly gone from delta to echo. Then I don't need this, but I'm going to calculate. Let us look at the calculation. Alpha, every time I'm going to take a frame, I'm going only on left-hand side. Anything down is negative, anything up is positive. That is what you should remember. Okay. Alpha is 0 kilonewton dash meter. If you go to Charlie, it is 30 kilonewton on the left side minus and 1.5 meter. If I go to delta, it is 130. One of the 30 is 1.5 meters from delta, other one is 4.5. You could have done a simplified method also, which I have told you in the previous modules. You could have taken that also. I could have done the same calculation from delta to alpha. If you see, it is 6 meters, and you have two 30 meters, 30 kilonewtons, which are amounting to minus 60. I could have got this value in a single shot by doing minus 60 into 3. I would have got the same answer if I go by the shortcut method. Here I have not done the shortcut method because I want to show you each calculation. You please follow the shortcut method as far as uniform loads are concerned. Right now, till now, you have uniform load of 30 and 30. Now I'm coming to X. You have to modify a little bit here. You'll have to be careful here because at X, I have a small distributed load of 97.5 going up and 15 going down. So please see the equation. I already have a calculated reaction of minus 337.5 at X. So I'm just writing that. Don't expect any lever, is already calculated. It is there. It is already a reaction moment, so I have written that. But let us look at the other values. Between D and X, I have a 97.5 with a center of gravity at 0.75 in the positive direction. Just come on the bottom of this, you have a 15, which is also at 0.75. But after that, you have two forces, which are minus 30 into 3 meters and minus 30 into 6 meters, which I've calculated from by look of the diagram itself, you can calculate. And it amounts to minus 545.62 kilonewton meter. This is the maximum BM you will get. This is the maximum BM you will get at X. But there's a small catch to it. I will leave that. Let me not confuse you more. Uh, when I show you the SF diagram, you will see that this SF is crossing just left of X. So that means just left of X, you would have had the maximum BM. But anyway, I can't go on with that minute calculation. So that is the reason I chose X. At least you can get a better value. So I'm getting minus 545. I will consider this. But if you look at the concept, you should have a slight greater value. Just left of X, you should have a greater value. But I will leave that. Okay. Now I've come to echo. The moment I come to echo, I don't have to split them. I needed this splitting of the forces only for calculation at X. I told you this in SF diagram also. Moment I come to echo, I'm going to take the full body. So for me, minus 337 still exists as a reaction moment. Please remember, reaction moment. 195 will generate 1.5 meters. And then you have the three 30s. I've given you 30s, 1.5 and all. This you could have done with a shortcut. If you see from echo to alpha, so I have around 9 meters. Echo to alpha, I have 9 meters. And I have three forces, which is minus 90. I could have done with a single shot of minus 90 into 4.5. I could have got this answer. If I go on doing that, my calculations and the pages will go more. That is why I stopped it. But that is the shortcut you need to do. So this is the answer as minus 450. Okay. Let us go to Foxtrot. Foxtrot also very similar. I've shown you all single method. You could have done again a shortcut method. From Foxtrot, you can see I have 3 fours are 12 meters till alpha. Half of 12 is 6. And then I have 120 newtons totally on the negative side. I could have done 120 into 6 in a single shot. I could have done this. So I'll leave that to you. Please use that. Okay. So it is coming to minus 180. Then at Foxtrot, let us see. Principle is similar. This time I've taken complete forces, and this is what is the shortcut method. I've shown you clearly the shortcut method here. I'm standing at Bravo. I have a reaction moment of minus 337 still existing. 195 into 7.5, 150 into 7.5. Your 45 is 0. Why? Because it is exactly at Bravo. I'll get an answer called 0. So finally, I've calculated all the BM where I've taken into account a constant reaction exactly at the center of the beam as minus 337.5, which is creating a Hogg moment. Okay. So let us look at these values. As I said, I've created an extra point called X, and I've shown you this. If you don't take X, can you see what value you will get? You will get at delta minus 80, 180, sorry, and echo, you will get minus 450. And in between, you don't know what to do. You'll have to create a curve, a parabolic curve, but you don't know the maximum value of the parabolic curve. By doing at X, you can get a better value of this parabolic curve. Okay. So let us look at the diagram for SF and BM. I've already taken the scales. You can see green is for SF and blue is for your BM. Let me start with SF. Okay. These are the values from the tables. You can have a look at the tables here. This is how it is coming. It is crossing just left of X. This is actually. And how did I find out? I found out because I calculate 22.5 at X. That is why I found out. Then after it goes up, comes to 45 plus, it is a point load at Bravo. It jumps down to 0. This diagram is no different from the previous uh, whatever solution we have done. I'm going to show you that. There's no different. It is exactly the same. Now let us look at BM. Since your SF lines are slanted and straight line, your BM has to be a curved structure. So I've tried to give a approximate curved structure. Maybe if you put in a software, you might get a better diagram. This is a manual drawn. This is a curved structure coming to Charlie. Coming to delta, this is minus 180. Remember, from here, it jumps down to that minus 545. And if you ask me that minus 545 is the value is at X, okay, that is the value at X. But as I told you, the SF diagram is crossing just before X. So basically, your value should have been a little bit more just left of X. But anyway, we are not going into that much accuracy. I'm leaving that. And at echo, it was, I think, minus 450. Then again, 180 at Foxtrot, and then 0. Now, look at the problem. What if I had not calculated at X? You would have joined delta and echo, and you would have put a slight parabolic curve and curving and returning back, peak reaching somewhere before X, and that will not be accurate because you don't know how much should I give you. So that is why calculation at X is giving me a better curve. Now, Before I started the BM calculation, I told you I'm expecting slightly two different curves on the left side of X and right side. You can see, yes, that is what is happening. And you have more bending moment or hogging stresses on the right side of X-ray, which clearly means that when you create any structure like this, I need a little bit more support on the right side than the left side. Okay. So I will leave that. I have done that little bit on the previous cantilever. Now, if you remember, I had shown a diagram like this, and a couple of videos are showing diagrams like this also, but I must admit the calculation did not take into account the BM reaction. That is why you got this value. So basically for me, I should stick on to a few things. BM at A should be 0, BM at B should be 0, and you should have maximum BM only at your X-ray. So which means the BM 0, if you go by this principle, this BM diagram is wrong because it did not take into account the reaction. If the account reaction was taken, you would have got the previous one. I'm just going back to the previous one. If the BM reaction was taken into account, this is what you will do. And this is the correct diagram. So please discard the last picture. That is why I've shown you with X. So this is your correct diagram for this question. That brings us to the end of this particular question. I've tried as much as maximum to get in all the principles. This video is a little bit longer, but it's worth it because uh, it took me quite some time to figure out what all things should be involved. That is the reason I've come up with the same question. And with my due diligence, I my confidence says that yes, this is the right way of solving. But anyway, I will leave it still to you. If anyone has got comments, you are free to give comments. Please don't hesitate. You can always give comments. If something is wrong, you can always correct me. And if something is wrong, I will correct and get in a new solution. I hope this video helped you. And I know in a couple of days there is an exam for phase two. I think it is coming up on 14th of May or something. So I hope it is useful for all those people who are going to appear for the exam. Vanakkam, namaste, namaskar. Please keep watching Jal Prayag. I'll see you soon.